Welcome to section 8.8, which is our Introduction to Power series. Please remember that I have designed this as a BC course, and because of time issues, I'm kind of condensing some things. So if you're looking at this from a Calc 2 standpoint, there's some things that I am not telling you about section 8.8. So I just want you to be aware, if you're looking back at this in Calc 2, that you realize that I've shortened this to try to get you enough information to get the most bang for your buck on the AP test. All right, so a power series. Your definition of a power series is right here. And that's if x is a variable, then an infinite series of the form, you've got that all nice right there, is called a power series. So it is infinite. Now, kind of the best thing I can tell you about the power series is that it can be used to represent the exact function. So for instance, if you have your e to the x or the sine of x, remember in section 8.7 we used a Taylor or Maclaurin series to estimate or approximate this function or one of the other functions we did. Well, the power series can actually represent the exact function. Now when you're looking at the power series, okay, you're looking at this guy right here, one of the things you can use to kind of help you separate, well, how is that different than what we did in 8.1 to 8.6? You've got an x here, okay? Those other series don't have the x, okay? So you've got, this is the main, or this is a power series, and then this is the more general form right here, because remember you can be centered at other numbers, just like the Taylor, you can be centered at anything. Maclaurin, you're centered at 0. So you're just looking for this little guy right here to see where you are centered. So to give you an example, okay, I've given you an example of a series centered at 0, so look at what we've got here. Okay, now this is an example of a series that's centered at -1, so look at your x being taken to the nth power. It's x plus 1, so very much like when we did parabolas and we had x squared or we had y equals x minus 1. Minus 1 actually moves you in the opposite direction. Okay, you actually move to the right one instead of to the left one. Kind of that same thing. X plus 1, that means you're centered at -1. If it's x minus 1, that is centered at +1. So it follows those same shifts and reflections. Okay, now, when they ask us about a power series, they're going to ask us about the convergence. And power series will have one of the three things be true. Okay, so if I'm centered at x equals 0, exactly one of them is going to be true. Okay? Well, the first thing that could be true is that the series converges only at the point it's centered at. Okay? The second thing is that there is a real number r greater than 0 such that the series converges absolutely for an interval. Okay? So instead of being convergent at just c, it's convergent over an interval. Okay? In that interval, we're going to try to set it up, okay? And I apologize for that being in your two different sections there. But we're going to find that interval of convergence. Okay? So we're going to want to find this interval. And what we like to do is, of course, go outward and talk about the radius. Okay? So instead of talking about an interval and doing you've got your x n1 or n2. Okay, instead of giving it as an interval, we're going to give it as a radius. So we're going to be looking at this guy. Okay, and that r is that radius of convergence. Okay. The third possibility is that it converges everywhere for all x values. Okay, so just to kind of recap, it converges only at the point you're centered at, or an interval, a finite interval, or converges for all x's. Okay, so only one of those three can happen at a time. All right, so let's see what we're going to do. Now, what we use on this interval of convergence, we are going to use the ratio test because the ratio test is easy to follow and it's pretty straightforward. Okay, so just to let us, as a little reminder, we're going to use the ratio test. So it is a series, it's a power series, but we can still use those other tests. So remember your ratio test, you're using the limit as n approaches infinity. You're doing the a sub n plus 1 term, the a sub n term, and we're looking at where it converges. So we're looking at where this is going to be less than 1. Okay, because if it's less than 1, we know it converges. If it's greater than 1, it's divergent, or equal to 0, it's divergent. Okay, so we know this guy right here. Okay, so what we're going to do is we're going to use the ratio test. Now, the reason why we're going to use the ratio test a lot is because of the nature of a power series. You're going to see a lot of the factorial in there. Okay, so you're going to see that factorial, you're going to know we use the ratio. Now, even if you don't see the factorial in there, we're just going to use the ratio test all the way through. If it doesn't pass that test, if it equals 1, then we know that we've got to use something else. But for the most part, I would say 95% of the examples you're going to run into are going to use the ratio test successfully. So looking at example 1, we're going to look at that ratio test. So we're going to get it started. The limit as n approaches infinity. We are going to do the n plus 1 term, so n plus 1 factorial times x to the n plus 1 all over the nth term, n factorial x to the nth. And then we're going to simplify that all out. Remember your factorial, n plus 1 factorial is just one term bigger than n factorial. So we will be left with that extra term, which is just n plus 1. And then x to the n plus 1 divided by x to the nth. Bases are the same. If you subtract the exponent, you're just going to come up with x to the 1 power. Just to refresh our memory on a little bit of absolute property notation, so to speak, if we have two things that are multiplied together inside absolute values, we can separate them. So sometimes we might need to separate it to kind of figure out what's going on. And sometimes, of course, we don't. All right, so you can either separate it or not. It does not matter to me which one you do. So we've got the limit as n approaches infinity. Well, when we're looking at this guy right here is going to infinity. So there's nothing my absolute value of x can do. It just doesn't matter. Okay. So it doesn't really matter what x is, I'm going to get infinity. So my ratio test, if I'm less than 1, I'm going to be convergent. If I'm greater than 1 or equal to infinity, I'm going to be divergent. So I am divergent everywhere except at that point at which I'm centered, okay? Because every power series is at least convergent at that point it's centered about. Now looking at this, you've got an x to the nth, so I know I am divergent for all x, but x equals 0, the point it's centered about. So we had case A. I'm going to get infinity for everything except when x is 0, okay? So I'm divergent for all x, but x equals 0. That sounds kind of weird. That's kind of weird. So my interval of convergence, I am just convergent at x equals 0. So if they were to ask me about the radius of convergence, I would tell them that r equals 0 because it doesn't go past that one point. Okay, so if you had a circle that is a point circle, the radius would be 0. So I know it sounds kind of weird, but if you are divergent for everything but the point at which you're centered about, your radius is 0. Okay, so we've answered the question. Interval of convergence, we are convergent at this point, which means my radius of convergence is r equals 0. Okay, so let's look at another one. All right, so looking at this one, I don't see the n factorial, but I know the ratio test is good for factorials and powers, so we do have the power, so we're ready to go with our ratio test. We're going to do the limit. Wow, I'm really writing that limit pretty messy. So the limit is n approaches infinity of the n plus 1 term. Remember, it's just the n plus 1, the x isn't changing, divided by the nth term. Now when I simplify that, I get the limit as n approaches infinity of, the 3's cancel, I have x minus 2 to the n plus 1, x minus 2 to the nth, so I have just x minus 2. Okay, so now I want to know when this limit is going to be less than 1 to be convergent. This time the x does matter. Okay, so this is going to be, this limit is going to be less than 1 when x minus 2, the absolute value of that, is less than 1. Because I don't have any n's left to increase to positive infinity. So I am literally going to be convergent when this happens. Okay. So if they wanted the interval of convergence, that would be -1 less than x minus 2 less than 1, and I would solve that interval. Okay. But here they really want the radius of convergence. So that's just going to be radius is equal to 1, okay? Because you're 1 away and 1 away, okay? Now, if they wanted the full interval, you would just add your 2 to both sides. So you'd have 1. And you could see that whole diameter is 2, so that radius would be half of that, which would be 1. So if they ask for the interval, by all means, give them the interval. And there's a little bit more to the interval of convergence. Right now, we're just really being asked for the radius of convergence. Okay, so just to let you know that interval, there's more to come. More in video 2. Oh, yeah, I'm going to split it into 2 videos because this might go a little long. Last example before we get to see each other in class. Now this one has it all. It has the factorial, it has the power, so it screams ratio. So we have the limit as n approaches infinity. We've got our -1 to the n plus 1 times x to the, all right, here we go. If I put in n plus 1 here, I'm going to have 2 times n, 2 times 1. So I'm actually going to have 2n plus 3. Okay? So if you're putting n plus 1 in here, you're going to have 2 times n plus 1 plus 1. So that's where I get that 3. All over, same thing. I get my 2n plus 3, parentheses, factorial. Okay, so that is the n plus 1 term. I'm going to multiply by the reciprocal of the nth term. So we need to kind of be careful about when it's the n plus 1 term. If you've got a coefficient in front of your n, make sure you take n plus 1 times that whole coefficient, so you're distributing. All right. Let's see what we get. Let's simplify. So you've got -1 to the n plus 1, you've got -1 to the nth, so you're going to be left with a -1, which really isn't that big of a deal because we've got the absolute value here. Now when I look at my x's, I've got x to the 2n plus 3, x to the 2n plus 1. So when you subtract those exponents, as you do when you're dividing, you'll be left with an x squared on top. On the bottom, we have n plus 1, 2n plus 1 factorial, and 2n plus 3 factorial. So the bottom is going to have more terms, it's going to have 2n plus 3, 2n plus 2, and then once it reaches 2n plus 1, that's where it's going to cancel with everything in the numerator. Okay. All right, so when I do some simplification here, and I really am not going to do much, I have that negative 1, which the absolute value of negative 1 is the same thing as the positive 1, so I'm not really going to do too much with that, so that's where the negative 1 is going. So I've got x squared times 1 over 2n plus 3 times 2n plus 2. Now we're taking the limit as n approaches infinity. When I do that, this little guy right here, as n gets really, really big, this is going to go to 0. So I will be left with x squared times 0. Well, it doesn't matter what x is equal to. Any number times 0 is still going to be 0, which is going to be less than 1. So this converges everywhere, okay, for all x's, okay, which means my radius would be infinity because it's all the numbers, okay. So we had an example of each one. So when I looked at this first case, it was infinity, that any number times infinity is still infinity, so this is divergent for all x's but the point at which you're centered around. This one, it did matter what x was. In order for this limit to be less than 1, the absolute value of x minus 2 has to be less than 1, so that gives us this little interval, and remember there's more to the interval, or this radius, a radius of 1. And then part 3, okay, you got 0 times x. It doesn't matter what x is equal to. You're always going to get 0 for that limit, so it's always going to be less than 1. So it is going to be a convergence of everything, which means your radius is infinity. Okay? So when we're looking at radius of convergence, we're just looking at where your absolute value is going to be, no, you're looking at where this limit is going to be less than 1, okay? So you're either going to get r equals 0, or wherever that's centered, r as an interval, okay? Or you're going to get r equals infinity, okay? So you're going to get a point, or you're going to get a number, or you're going to get infinity. Okay, so all 3 of those cases. All right, I'll see you in video 2. But I want you to watch video 2 so that you'll know the whole picture about this guy right here. Whenever they talk about interval, the whole